If you only know one way to find turning points, you're going to get cooked in the trial exam. I'm going to show you 3 ways to attack this cubic and classify the turning points properly. Let's get into it.
Find the coordinates and turning points of f of x equals x to the power of 3 minus 6x squared plus 9x, and state whether they are maxima, minima, or points of inflection. Alright, so the easiest way to do these questions is step 1, get the first derivative. So first we find f dash x to be 3x squared minus 12x plus 9. Now we need to find when the first derivative is 0, because when the first derivative is 0, that's when the curve is stationary. So we need to solve equals 0. So dividing both sides by 3, we get x squared minus 4x plus 3. So we can rewrite that as x minus 1 times x minus 3 equals 0. And from there we know that f dash 1 equals 0 and f dash 3 also equals 0. So I know we have turning points at x equals 1 and x equals 3. So f of 1 equals 1 minus 6 plus 9, which is 4. And f of 3 equals 27 minus 6 times 9 plus 27. So our turning points are 1, 4 and 3, 0. So now we need to find the nature of these turning points. So the actual easiest method to do that, we just find our second derivative. So we know that f dash x is 3x squared minus 12x plus 9. To get the second derivative, we then get 6x minus 12. And now all we do is we substitute the value of x for each of those turning points. So the first turning point is at 1, 4. So we put in 1 for x, which is 6 minus 12, which is negative 6, which is less than 0. Therefore, at 1, 4, we have a local maximum. And then we check for x equals 3, we end up with 18 minus 12, which is 6, which is greater than 0. Therefore, we have a local minimum. So final answer we have as 1, 4, local max, and 3, 0, local min. Alright, so that was the first method and my personal favorite solution. Moving on to another way of answering the question. So I've copied down our main information from before. We have f of x equals x to the power of 3 minus 6x squared plus 9x. We calculated our turning points at 1 and 4 and 3 and 0. And we have the first derivative as 3x squared minus 12x plus 9. And the first derivative is 0 when x is 1 and when x is 3. So another way of determining the nature of those turning points is to test the first derivative. So what I mean by test is that a maximum is like a mountain and a minimum is like a valley, which means that before the turning point, we are sloping up, and after the turning point, we are sloping down. And for the minimum, before the turning point, we are sloping down, and after the turning point, we are sloping up. So if I know there's a turning point at x equals 1, I know there's a turning point there. Now, whether it's a maximum or minimum, I've got to figure out. So let's see what happens when we take a value of x less than 1. How about 0? Let's see f dash 0. That is 9. And then we shall see a value of x. And then we'll try a value of x which is greater than 1. How about 2? Let's have a look at f dash 2. What do we get? We get 3 times 4 minus 12 times 2 plus 9. 12 minus 24 plus 9 minus 3. So f dash 2 is minus 3. Now this is negative, so this is sloping down. And f dash 0 is positive, so this is sloping up. So if we go sloping up to flat to down, well, we found a maximum here. So therefore 1 comma 4 is a local max. Now let's consider when x equals 3. So when x equals 3, f dash 3 equals 0. So now let's first try a number lower than 3. Let's try x equals 2. Well, we've already solved that over here. So we know that when x equals 2, f dash 2 equals minus 3, which is negative or sloping down. Now logically we just have to try a number which is greater than 3. Simplest one to solve would be 4. So we try x equals 4 and we substitute that in. F dash 4 equals 3 times 16 minus 12 times 4 plus 9. 48 minus 48 plus 9 equals 9, which is positive. And just like that, when we have a slope down and then we're stationary and then we slope up, well, that is a minimum. So therefore 3 comma 0 is a local min. Now you might be asking, why is it local? Why specify the word local? Well, the main reason we specify local is because it's not a true max and it's not a true min in this case. So you can imagine if I substituted in f of 100 and I ended up with 100 cubed minus 6 times 100 squared plus 900, that's far greater than our little local maximum, which was at 4, right? And likewise, if it was f of negative 100, I'd have negative 100 cubed minus 6 times negative 100 squared minus 900, which is also far, far less than our local minimum of 0. So we come to our final answer, which is the same as our previous solution of local max at 1, 4 and local min at 3, 0. All right, let's move on to the next method. As before, I've kept our same information we calculated. And now this third method is great when you're a bit confused, you're a bit stuck, you're having like a brain fart or something like that, right? So when in doubt, just graph it out. So I already know that our turning points are 1, 4 and 3, 0. And to make my life easy, I'm just going to rewrite our initial expression, f of x, as x out of x squared minus 6x plus 9, which is x out of x minus 3 squared. Okay? Then I draw a very, very rough graph. Now, this is all going to be assuming you're doing this in the calculator-free portion of your assessment. If you're doing this in the calculator section, well, Obviously, it kind of trivializes the whole thing, but this is the assumption that this is a calculator-free section, okay? We have interception of the x-axis when x is 0 and when x is 3. So I know I have an intersection here, and I know I have a intersection here. I also know I have a turning point over here, 1, 4. I also know this is a turning point here, 3, 0. So quite simply, I'll just start making my little graph. I'm not feeling that great. I just want to know for sure. This question's like irritating me. Could be anything. So when in doubt, just graph it out. So let's just check for f of 2. We end up with 2 cubed minus 6 out of 2 squared plus 9 times 2, which is 8 minus 24 plus 18, which is 2. And then we can check f of -1, which is -1 minus 6 minus 9 minus 16. So we're all the way down here. And let's have a look at f of 4. We end up with 4 cubed minus 6 times 16 plus 9 times 4, which is 64 minus 96 plus 36, which is 4. And let's just check f of 5 as well. Why not? F of 5, 125 minus 6 times 25 plus 45, 170 minus 150 equals 20. So I know that's up here somewhere. So I just roughly put in my graph. Yeah, I know mine. Drawing could use a lot of work, but hey, that's why I don't do drawing when I do my own solutions, right? So I can easily see from here, I know for a fact from the first derivative that this is a turning point here at 1, 4, and I also know for a fact this is a turning point here at 3, 0. I can just see straight from the graph, 1, 4, local max, and 3, 0, local min. If you're ever confused, this is the easiest way to do it. It requires the least amount of brain power, and sometimes, even the best of us, we need an option like that. But 3 ways, all leading to the same final answer. The best students don't panic when method 1 gets messy. They switch to method 2 and keep moving. Subscribe if you want the full playbook. And if you're in year 12 this year and you sit in the methods exam, check the link below for my walkthrough packs.